Welcome to Chapter 10, Section 2 on the introduction to conic sections and, more importantly, parabolas. So before we talk about parabolas, let's talk about what conic sections are. And so I want you to imagine two cones that are placed on top of each other such that their tips are touching. So we have two cones that are stacked on top of each other, and we intersect these cones with a plane. And so imagine the two cones and we're slicing it with a sheet of paper. And what we want to look at is on that piece of paper, what part of the cone is touching. And if you notice, we slice this cone at some spot just above the intersection of the two tips of the cones, the two vertices. And if we look at that plane, we see we have an intersection of a circle. All right, the cone traces out a circle, and that circle changes size based on where we slice. If we slice closer to the base, we get a bigger circle in red. All right, and we can slice up on the other cone, and you can see the radius of the circle changes as we move up and down the two cones. Now, we already dealt with circles. We dealt with the equations of a circle and all that, but today we're going to focus on something a little different called a parabola. All right, and we've seen parabolas before, and what we're going to do is we're actually going to change the angle at which we intersect, and we're going to change the angle of our plane here to 45 degrees. So we're taking this and we're cutting the cone at a 45-degree angle, and if we look at the intersection, well, what's on our plane is the shape of a parabola. And once again, we can change that, moving it up and down. And so as we move up and down the cones, we get different parabolas traced out. And if we move left and right, it's still just different parabolas, and we're changing the stretching and compression of the parabola. So if you intersect the plane at different angles, you're going to get different shapes. And the four basic shapes you get are circles, ellipses, parabolas, and hyperbolas. We've already talked about circles in the past, and you've seen parabolas in the past, but that's what we're going to focus on in this video is what is a parabola and how do we define it. So let's talk about, first off, the general equation of conic sections can be defined by this ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, when a, b, c, d, e, and f are all just constants. They're just numbers. And we can use this to derive different expressions and different equations for the conic sections, but we can also take a different approach. We can define it using some geometric measures. But first, let's talk about what you know about a parabola so far. So far, in Algebra 2, you were told that a parabola was some function f of x equal to ax squared plus bx plus c, where a, b, and c were constants, and you could do all sorts of stuff with that quadratic equation and solving and factoring, and you could graph it, and you even maybe had the vertex form of a times the quantity x minus h squared plus k, where hk was your vertex. All right, now this was a parabola. This still is a parabola. However, this is only a certain type of parabola, one where y is a function of x. Today we're going to look at a more general term or a more general form of what a parabola is. So let's define a parabola in more general terms. A parabola is a set of all points, both x and y, so the coordinate xy, in a plane that are equidistant. Now, what does that mean, equidistant? That means that it has the same distance from a fixed line called the directrix and a fixed point called the focus, not on the line. All right, now I'm going to show you this graphically in a moment to nail these concepts down. So basically, a parabola is a set of all points where it's the same distance from one point and a line, and it shapes out a parabola. All right, now the general equation, we have two general equations. We can have this one right here where we're talking about a vertical axis of symmetry, and that's more of what you're used to. Okay, you're used to that vertical parabola, the one that opens up or opens down, and that's the quantity x minus h squared equal to 4 times p times the quantity y minus k. All right, or you can have the variable switched so that we have y minus k quantity squared equals 4p times quantity x minus h. What's the difference between these two? Well, they have different axes. Now, what are we talking about the axis here? Well, all parabolas are symmetrical about an axis. And the normal parabolas that you were used to in Algebra 2 were vertically aligned parabolas, so they have a vertical axis of symmetry. Well, you can also have a horizontal parabola, and it'll have a horizontal axis of symmetry, and this is the form right here. All right, now, what is this directrix? Well, this is the line that we are equidistant to, and in a vertical parabola, that line is defined by y equals k minus p. So whatever number we're subtracting from y minus p, this coefficient of y, then that's our directrix. In the horizontal axis, we have x equals h minus p. All right, and then this value right here, the distance, the focus lies on the axis p units away from the vertex. So the distance the directrix is away from the vertex is the same distance that the focus is away from the vertex. So let's look at a diagram here to see the concept. All right, so we have a parabola here, and the function of this parabola is of no concern. It doesn't matter what the function is. But notice the parabola, we have a vertex right here. So this point we call the vertex. Okay, now this dotted line right here is the axis of symmetry. And so this axis of symmetry is vertical, so this is a vertically aligned parabola. So we have a focus somewhere. We have a focus that is actually going to be right here at this point. And if you look at this distance right here, that is p. That is p units. Whatever p is, it's that distance from the vertex to the focus. Well, we also have this distance here to our directrix. That's also p. And this is our directrix, and since it's vertically aligned, this is y equals k minus p. That is the equation of that horizontal line. Now, what the definition of a parabola tells us is that at any point along this parabola, so any point, let's just pick this point right here, okay? So this point right here, it is the same distance from the directrix. So this distance from here to here is the same as the distance from here to here. So those two distances are the same, and every point along this is going to be the same distance from the line and the point. Right? That's the definition of a parabola, and it's going to give us this parabolic shape. Okay, so let's talk about some other aspects of this. If it's vertically aligned and it's up, this p has to be positive. So p is greater than 0. So that means in our equation, for instance, this equation, if you want to know what this is actually x squared is equal to 4y. That's this equation. So you might ask, well, wait a minute, what's p in this case? Well, p is 1 because of the form x minus h quantity squared equals 4p times y minus k, that quantity. So we look at, well, what are we multiplying by y? We're multiplying y by 4. So 4 times p equals 4, so that means p has to equal 1, h is 0, and k is 0, because we're not subtracting anything from x and we're squaring it. We're not subtracting anything from y. So this tells us how to align our directrix. Our directrix is 1 unit away from the vertex. Our vertex is hk, so the vertex is going to be at 0, 0. That's our vertex here. And we know our focus is 1 unit above, so this is going to be at 0, 1. And our directrix is going to be y equals k minus p, so that's y equals negative 1. And so we've identified the horizontal line and the point at which all points along the parabola are equidistant to that point and that horizontal line. Okay, if we look at this same type of parabola, vertically aligned, but it's open down, the only difference, everything's still the same in that we still have the same general form of x minus h quantity squared equals 4p times the quantity y minus k. So hk is still our vertex, and this distance here is still p, and the distance from here to the focus is still p, but the difference is p is less than 0. So we have a p that is a negative 1 in this case, and this function right here is in fact x squared equals a negative 4y. And so p is a negative 1, h still 0, k still 0. All right, now what if we have a horizontally aligned parabola? Then we're looking at the general form of y minus k quantity squared is equal to 4p x minus h. Okay, where hk is still our vertex, so this vertex right here is still hk, and we have our focus, which is going to be at this point here, and we have our directrix at this vertical line, x equals h minus p. Okay, well, what's p in this case? Well, p is the distance from our vertex to our focus, and p is also the distance from our vertex to our directrix. So these are both p. When we're open to the right, so when we open our parabola to the right, that is when p is greater than 0. When we open to the left, that is when p is less than 0. So let's look at the example where, let's say we want to find the standard equation of a parabola that has the vertex at the origin, so the vertex is at 0, 0, and it has a focus at the point 2, 0. Okay, so there's a few things that tells us. All right, first off, if the vertex is at the origin, this tells us h, this tells us k. So both h and k are 0. Okay, h is 0, k is 0. Now, because the focus is at 2, 0, this immediately tells us where this is opening up. So if we look at 0, 0, and we look at 2, 0, 1, 2, 0, if this is our focus right here, well, then that means our parabola has to open this way. It has to open to the right, okay? Because the focus is always inside of the bowl of the parabola, because that's the point where that everything is focusing. And we'll talk about some applications of a parabolic curve and why it's called the focus in class a little later. All right, but that tells us that we're oriented to the right, so we know we're going to use the form y minus k quantity squared equals 4p times x minus h. Okay, so our goal is we want to find k, h, and p. Well, we already know h and k are 0, so this is going to be y squared equals 4p times x. But we don't know what p is. Well, remember, p is our distance from the vertex to the focus. Well, if our focus is 2, 0, the distance from our vertex to our focus is 2, so that means p has to equal 2, and so y squared equals 8x is our general equation of the parabola that has a vertex at the origin and a focus at 2, 0. So what I want you to do is look on page 741, and I want you to try 2 problems before coming into class tomorrow. Try number 33 and number 34. Okay, they're very much like the example that I just did. So try those before you come into class, and we're going to continue working with these parabolas in class tomorrow. Thank you.